Hi guys, this is Dr. G here, and in this particular video I will give you a brief introduction to organic chemistry, and also we will talk about hydrocarbons and alkanes. So in this chapter you will need to have a few chemistry skills from your previous general chemistry knowledge. So I would expect you to know about drawing electron dot formulas. You will know about the shapes of molecules, and also you may want to have some idea about balancing chemical equations. So with that, let's talk about organic compounds. So organic compounds are basically compounds that contains carbons, or in other words, organic chemistry is basically the study of carbon compounds. And all the organic compounds contain not only carbon, they also contains hydrogen, and sometimes they also contain other non-metal atoms such as oxygen, sulfur, uh, nitrogen, phosphorus, and halogen. So these are the most common elements that you will see in organic compounds. So basically organic compounds always will contain uh, carbon and hydrogen, and sometimes certain organic compounds could have atoms such as halogens, oxygens, sulfur, nitrogen, and phosphorus. Okay, and these organic compounds are very common in nature. Okay, and if you touch something that surrounds you, you randomly try to grab something that surrounds you, and most of the times it will be an organic compound. So basically organic compounds are extremely common in earth, and most of the uh, plastics or materials or wood materials or things like medicine, food, or things like cosmetic materials, they are all categorized as organic compounds. Okay, so organic compounds are everywhere, so it is very important to understand about these organic compounds, especially in health science. And here's the other important thing. Okay, so basically we just learned that organic compounds primarily contains atoms such as carbon and hydrogen, right? So they may also contain secondary atoms such as oxygen, nitrogen, sulfur, phosphorus, or halogens. Most common halogens in organic chemistry are fluorine, chlorine, bromine, and iodine. Okay, so these are the primary atoms. Okay, and are they metals or non-metals? What do you think? Are they metals or non-metals? Carbon, hydrogen, oxygen, nitrogen, phosphorus, halogens. They are found towards the right-hand side of the periodic table, right? So therefore, these elements are actually metals, or sorry, non-metals. All these are non-metals. So organic compounds usually composed of non-metal atoms, okay? But sometimes you could see metal atoms in organic compounds, especially metals like copper, lithium, magnesium, sodium. Those are some of the common metal ions that could be present in organic compounds, but 99% of the times the organic compounds are composed of non-metal atoms. Okay, so as compared to inorganic compounds, okay, organic compounds are composed of non-metals. And then let's talk about the bonding of organic compounds. Okay, so in inorganic chemistry we learned about two different kinds of chemical bondings, right? So we learned about covalent bonds, and then we also learned about ionic bonds, right? So we learned about covalent bonds, we learned about ionic bonds. These are the two types of bonds that we learned in inorganic chemistry. So the difference between covalent and ionic is that, of course, in covalent compounds you have non-metals, and these non-metals share electrons. These non-metals share electrons, right? And in ionic compounds, you have a metal cation. Okay, so you have a metal cation and a non-metal anion. Non-metal anion. So basically, you have a metal cation which is formed by losing electrons from a metal atom, and then you have a non-metal anion which is formed by gaining electrons by a non-metal atom, right? So you have a metal cation and non-metal anion in ionic compounds, and they basically interact through electrostatic interactions, right? So they basically interact through electrostatic attractions. So in ionic compounds, one atom is gaining electrons, the other atom is losing electrons, and then they sit next to each other because of the electrostatic interactions. We call them ionic bonds. But in covalent compounds, you only have non-metal atoms. And they share electrons. Non-metals are very greedy, right? So no one wants to lose electrons, right? So therefore, non-metals share electrons and then form covalent bonds. So when it comes to organic compounds, we just learned that organic compounds are primarily made up of non-metal atoms. So organic compounds are supposed to have what type of bonds? They are supposed to have covalent bonds. Okay, so that is something that you should know by now, of course, by understanding. Okay, and then let's talk about their properties. Okay, we will try to talk about the properties of organic compounds as compared to inorganic compounds. So let's say we will talk about properties of organic compounds as compared to water, which is actually a very common and a very important inorganic compound, right? So we will talk about the properties of organic compounds as compared to water. And then organic compounds, as I mentioned earlier, they have covalent bonds. Why? Because they have non-metal atoms. When you have non-metal atoms, you are going to have covalent bonds, of course. And then they are going to have low melting and boiling points. So let's take an example. Let's take a common organic compound, sugar. Sugar is a common organic compound. Okay, let's compare sugar with salt. Let's take table salt for an example. Okay, so you have sugar as an organic compound, you have table salt or salt as an inorganic compound, and when you compare the melting points and boiling points, of course you know that it is easy to melt sugar, right? So you put some sugar into a pan and you turn the heat up, and then they will melt, and then it will make a sugary solution, a caramel type thing, right? So basically organic compounds have low melting and boiling points. They are easy to melt, they are easy to boil. But if you try to melt a spoonful of salt, okay, salt is very hard to melt. Okay, you need more than 800 degrees Celsius. Okay, you need more than 800 degrees Celsius to melt salt. So ionic compounds typically have very high melting points and boiling points, and that is why you for a small scale fire, okay, you can pour some salt. Okay, you can pour some salt and it will get rid of the small scale fire. But of course, don't put salt into a large scale fire. Okay, do not put salt into a large scale fire. Why? Because the temperature on large scale fires are very high, and then it will also easily melt salt, and then the fire will be intensified. So don't put salt into a very large fire. Okay, but anyway, the take home message is organic compounds have low melting and boiling points, and then inorganic materials or inorganic compounds tend to have high melting points and boiling points. But here's the thing, this is not 100% accurate all the time. Okay, there could be organic compounds with very high melting and boiling points. Okay, there could be organic materials with very high melting and boiling points. So this is not always correct. Typically organic compounds are highly flammable. okay, they are highly flammable. They can easily burn in oxygen. Okay, a very common organic compound is gasoline that you put into your car. Okay, so gas, they are highly combustible, or something like alcohol or ethanol. Okay, let's take ethanol, the alcohol that people use to get drunk, right? So ethanol is highly flammable. Okay, they catch fire very easily. So organic compounds tend to catch fire very easily, but inorganic compounds, they are not very flammable. Okay, as compared to organic compounds, inorganic compounds are not highly flammable. And how about the solubility? Will they be soluble in water? Will organic compounds like water? I mean, water is an inorganic compound. Will organic compounds like water? Uh, Typically, they don't like water. Typically, they don't like water. Imagine a bottle of vegetable oils. You try to mix it. You try to mix it with water. What will happen? It will form two layers, right? Water and vegetable oil will form two layers, and they will not be miscible with each other. So they are not soluble in water. Organic compounds tend not to be soluble in water. But later on, you will learn that certain organic compounds like water. Okay, but overall, as a whole, organic compounds do not like water. Okay, do not like water. And you might already know why. Let me remind you why, but we will talk about these things in much more detail. Okay, water is a polar compound. Water is a polar compound. Why is it polar? Because excuse me. Water is a polar molecule because it has a negatively charged oxygen atom, and then partially negative, of course. They are partial charges, and you have a partial positive charge on hydrogens, right? So you have a negative pole and a positive pole. The negative pole is actually on oxygen, and the positive pole is on hydrogen. Okay, so water is a very highly polar molecule, and polar molecules, or extremely polar molecules, tend to form polar interactions with the molecules that are around water, right? So water prefers to interact with other molecules through hydrogen bonds, which is basically a very highly polar intermolecular interaction, hydrogen bonds, right? So organic compounds are not polar. Organic compounds are mostly what? Carbons and hydrogens. I mean, carbon hydrogen bond is not a very strong dipole. Okay, carbon and hydrogen, they both have similar electronegativities. So therefore, their dipole is very small. So therefore, organic compounds are non-polar. So you basically have a polar water molecule and a non-polar organic compound. Then they are not going to mix with each other. Remember, in inorganic chemistry, we talked about miscibilities, right? Or solubilities. When it comes to solubility, like dissolves like. That means you have to have similar interaction types to mix with each other, right? So if you have a polar molecule, it prefers another polar molecule. So water prefers another polar molecule to mix, right? And then organic compounds are non-polar, so of course they tend to stay away from water because water is polar. Organic compounds are non-polar, so when they don't like each other, or when they don't mix, they form a bilayer. They basically form a bilayer. Okay, usually the water layer stays at the bottom because of the high density, and the organic layer will stay on the top. Okay, so this layer is organic and this layer is water. Okay, so when you try to mix them, they will form a bilayer. All right, so we have learned about these things before, but this is just a introduction. Okay, so let's summarize what we learned up to now. Okay, so organic compounds are compounds that contains carbon and hydrogen atoms, primarily carbon and hydrogen atoms. They could have atoms such as oxygen, nitrogen, phosphorus, sulfur, or halogens. Rarely they can have those type of atoms. And then very rarely you can also have metals, but they are not very common. Okay, so usually organic compounds contain non-metals. So when you have compounds that are made up of non-metals, the bonding is going to be covalent bonds, right? So organic compounds have covalent bonds, and they have very low melting and boiling points, and they are highly flammable, and also they typically do not mix with water. They are not soluble in water. Okay, so this is what we learned. All right, so this slide also basically summarizes what we just learned. Okay, so you can go through it. Okay, so in here this slide basically compares propane, which is an organic compound. Okay, propane, it is C3H8, propane, versus sodium chloride. Of course, you know propane is a gas, it comes in a tank, right? And then sodium chloride, salt, it's a solid, right? So basically propane is highly flammable, it catches fire very easily. Sodium chloride, you need to burn it to more than 800 degrees Celsius if you want to melt sodium chloride, so very hard to melt. And then salt, of course, soluble in water, and propane does not like water. Okay, does not like water. So these are some of the characteristics that we learned about organic compounds and their comparison to inorganic compounds such as water or sodium chloride in this case. And I really like this table. This is actually directly from your textbook, which is the Timberlake textbook. Okay, and if you understood what I just mentioned before, okay, you should be able to understand this table. This basically summarizes the things that I just mentioned. So just go over this slide and then see if you understand the material. And when you're studying for the exam, I would recommend that you just basically try to understand this table, which will be more than enough for your exam. All right, guys, let's quickly do this study check. Okay, so in my videos, I usually have study checks. Okay, after a few slides, I will always give you a study check. And then what I want you to do is I want you to pause the video and then see if you could try the study check by yourself before I explain it. Okay, so once again, let me explain it to you. You will pause the video and then try it by yourself and then see if your answer is correct by playing the video again. Okay, all right, so let's do this. Identify each of the characteristics as most typical of compounds that are inorganic or organic. A, it has high melting point. If a compound has high melting point, it will be what? It will be inorganic. Let's put I for inorganic. It is not soluble in water. B is it is not soluble in water. Organic compounds are not soluble in water most of the times. C, it has the formula CH3, CH2, CH3. This is organic. Why? Because you only contain carbon atoms and hydrogen atoms. So if you only have carbon atoms and hydrogen atoms, that is definitely an organic compound. Okay. D, it has the formula MgCl2. MgCl2. MgCl2 is the formula that you have. That means it is inorganic. Why is it inorganic? Because you don't have any carbons or hydrogens. So if you don't have any carbons and hydrogens, that is definitely inorganic. And of course, in this inorganic compound, you're supposed to have a metal cation and then a non-metal anion, right? So magnesium 2 plus and then Cl minus. Okay, so this is an inorganic compound. It burns easily in air. Organic compounds burn easily in air. And then F, it has covalent bonds. Organic compounds have covalent bonds. So these are your answers, okay? Organic compounds have covalent bonds. All right, let's move to the next slide. This is your solutions as a summary. So please feel free to pause the video and then write down the answers if you have to. All right, so let's let's stop the video right here. Okay, so that is our introduction to organic chemistry. So basically in the next video I will talk about hydrocarbons in more detail. Okay, let me know if you have any questions, guys. You guys have a good one.